Hi everyone, my name is Sakshi, and in this video, we are going to solve a very common interview problem, subsets. This is the problem number 78 on LeetCode. Let us first look at the problem statement. Given an integer array nums of unique elements, return all possible subsets, that is the power set of the integer array. The solution set must not contain duplicate subsets, and we can return the solution in any order. We are going to solve this problem in 3 simple steps. Firstly, we'll look at the recursion tree for this problem. After that, we'll implement our algorithm. And after that, we will analyze the time complexity and the space complexity of our algorithm. Now let's first jump to the step 1. Here I have drawn the recursion tree for this particular example, 1, 2, 3. Here the left branch indicates that we do not include a particular element into the subset, and the right one indicates that we include that element. Now that particular element depends on the index. So we start from index 0, that is the element 1. We do not include 1, we get an empty subset, and if we include it, we get 1. Similarly, we do it for 2. Here we get an empty subset, we get 2. Not including 2, we get 1 here, and including it, we get 1, 2. For 3, we get an empty subset, 3, 2. This becomes 2, 3. This remains 1. This becomes 1, 3. This remains 1, 2. And this becomes 1, 2, 3. Now, all the leaf nodes represent the subsets which we need as solution, right? How do we count the number of subsets which we are going to generate? Look at this recursion tree. For an array of unique elements of size n, we are going to generate 2 to the power n subsets. How? For every element, we have 2 possibilities. Either we include that element or we exclude that element from the subset. Since we have 2 possibilities for every element and there are n elements, we will generate 2 to the power n subsets of a particular array of size n. Also, we can derive this from the number of leaf nodes of this recursion tree, which is 2 to the power n. Now we have done part 1 of our process. We will jump to part 2, which is the implementation of our algorithm. We'll do it in C++. We will write a recursive function. I'm naming it recurse. Now look at the inputs which I am providing to this function. Nums, which is the given array, integer n, which is the size of the given array, index is the current index. I'm taking a temporary vector in which I'll be storing the elements, and finally I'll push the temporary vector into our final vector of vectors, which is our output vector. And that output vector, I'm considering it to be RET. We will write this algorithm according to our recursion tree only. So first thing, we do not include that element. If we are not including that element, we'll just pass on to the next index. That is, I'll call this function for next index. Everything else remains the same. And if I include that element, that means I'm pushing that element into temp. And after that, I'm calling recurse for index plus 1. Also, I will do pop back here. Now, why I'm doing pop back? Because look at this. Let's say temp is here. The temp is the empty subset. Now we go to 1. Now temp is 1. Now if we go to 1 here, and after that we go to 1, 3. Now we push temp equal to 1, 3 into RET. Now we want to push another 1, 2 and 1, 2, 3 as well. Now, so we need to pop 3 out to go to 1, and After that, we'll go to 1. We are not popping out 1 here because it is the case of not including 2 here, right? So we go to 1, and after that we include 2, and we do the same process. So this we do for all the branches of this tree. Here I'll return. Now one thing which is left in this function is, when will I push temp into the RET vector? So this we know, when we reach the leaf nodes, we'll push temp into the RET vector. And when do we reach the leaf node? When index is equal to n. Then we reach the leaf node and we'll push temp here and we'll just return. Now to call this function, I will get the size of my array. I'll define a vector temp, another output vector RET. I'll call the above function using nums, and I'll start from the index 0. Index will be 0, temp, and RET. And I'll return RET. Now let's check. So for 1, 2, 3, it is giving the correct output. And you can see that this is the order in which we have our nodes. Since we have written this algorithm based on our recursion tree only, so this has to be the same, right? Now let's submit this. We are good to go. So we have completed the part 2. Now let's come to part 3. Let's complete the easy part first, the space complexity. We are using an extra vector temp here, and the maximum value or maximum size of temp can be n if we have all the elements, right? So that means the maximum space complexity of this algorithm can be n. So the space complexity is order n, and we are not considering the space used by this vector because this is the output vector. And to find the time complexity, so how to find the time complexity of a recursive algorithm? We find the number of recursive calls and then we multiply it by the time complexity of one recursive call. Now how do we find the number of recursive calls? Look at this. We have one call here, 2 calls here, 4 calls here, 8 calls here. That means it is going in the manner 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. Because there are 3 elements here, it goes till 2 to the power 3. Now, if we have n elements, it will go till 2 to the power n. So, total number of recursive calls will be 1 plus 2 plus and so on up to 2 to the power n, which is a GP, and the sum of it will be 2 to the power n plus 1 minus 1 order of 2 to the power n. So, the number of recursive calls are 2 to the power n. And what is the time complexity of one recursive call? The time complexity of this is order 1. This is also order 1. This is order n. Why? Because the time complexity of pushing a vector into a vector of vectors is the number of elements in the temp vector, right? So here the number of elements in the temp vector can be maximum n. So the time complexity of this if condition will be order n. So the total time complexity is n into 2 to the power n, which is the number of recursive calls into the time complexity of one call. So this is the complete solution along with the time complexity of this problem. If you like this video, please like, share, and subscribe. And if you have any doubts or comments, please leave them in the comment section below. And that's it for today. See you in the next video. Bye-bye.